Section 8.6, identifying special quadrilaterals. I cut and pasted this out of the book. Let's look it over. The diagram below shows relationships among the special quadrilaterals you have studied in this chapter. Each shape in the diagram has the properties of the shapes linked above it. For example, a rhombus has the properties of a parallelogram and a quadrilateral. Let's look at rhombus. A rhombus linked above it is a parallelogram. Linked above it is a quadrilateral. Okay? A square has the properties of a rhombus and a rectangle, a parallelogram and a quadrilateral. A kite only has the properties of quadrilateral, etc. Okay, so we need to keep all of our shapes organized in our mind so we know which one has the properties of what. You see the ones that could have at least one pair of opposite angles congruent. Okay, not a trapezoid. A kite would probably work. I've got rhombuses, squares, rectangles. Okay, trapezoid doesn't work, etc. So you have to remember all the properties of all the shapes that we have learned and try to classify them. First example, I left the solution on this one because it had really good diagrams, pictures. Quadrilateral ABCD has at least one pair of opposite angles congruent. What types of quadrilaterals meet this condition? Okay, this is our key word here, at least one pair. It could have more than one pair, but it's at least one pair of opposite angles are congruent. So I would actually go back here and look. So here we go. There are many possibilities. Parallelogram has these opposite angles and these. A rhombus, rectangle, square, kite, are all possibilities. Next question. What is the most specific name for quadrilateral A, B, C, D? Okay, in the diagram we see that AE is congruent to EC and BE is congruent to DE. So the diagonals bisect each other. So I've got, let's think about that. Theorem 810 says that it's a parallelogram. Rectangles, rhombuses, and squares are also parallelograms. However, there is no information given about the side lengths or angle measures of ABCD. So you can't determine whether it's a rectangle, a rhombus, or a square. We don't know if those are 90 degrees. Okay, we don't know if that's 90 degrees. We don't know any other information, so you can't classify it any further. All right. Identify a quadrilateral. Is enough information given in the diagram to show that the quadrilateral PQRS is an isosceles trapezoid? Explain. Let's see. I've got these are congruent. It's a quadrilateral, so it should add up to 360. I could do 74 plus 74 plus 106 plus x equals 360. This gives me 148. 8 and 6 is 14. 4, 5. 254. I could find a calculator, but it's sort of fun doing addition and subtraction. 6. Okay, x is 106, which there's x. So I've got 106 and 106, 74 and 74. So yes, there is enough information. The diagram is sufficient to show that PQRS is, in fact, an isosceles trapezoid. You try. Quadrilateral DEFG has at least one pair of opposite sides congruent. What types of quadrilaterals meet this condition? DE, it's always dangerous to draw a sketch because you never know. One pair of opposite sides congruent. So those are congruent. Let's see, what types of quadrilaterals meet this condition? I know a parallelogram has the opposite sides congruent. A square, a rectangle, a rhombus. It could be a trapezoid too. If you think about a trapezoid, if it were like this, and those were congruent. I think that's it. Good job. You try again. Give the most specific name for the quadrilateral. Explain your reasoning. I have these two congruent and these two congruent. And that's really all we know. Let's see. Yep, we don't know anything else. So when you have consecutive sides not congruent, but opposite, these sides being across from each other and congruent, those sides being across, but consecutively they're not congruent, that is a kite. Okay, here's another one. Let's see. This is 64, that's 62, 75 and 80. 80 plus 64 is 75 plus 62. Diagonals are not congruent. The opposite sides are parallel. So I think the only thing I can say about this is a trapezoid. There's only one pair of parallel sides. The diagonals do not bisect each other. It cannot be a parallelogram. Cool. That's it. Trapezoid. All right. So I know these are congruent, and I know this diagonal is bisected, but we don't know about this diagonal. I know that this piece is 9, but I don't know about this one. So I know nothing about this one, so we're just going to label it a quadrilateral. There's not enough information to narrow that down at all. Okay, error analysis. A student knows the following information about quadrilateral MNPQ. MN is parallel to PQ. MP is congruent to NQ, and angle P is congruent to angle Q. So I've drawn it very misleading that it actually looks like an isosceles trapezoid. Let's see if I can draw it a different way. Okay, with this being 90 and being congruent, these being congruent, and that's a square. I can probably draw a rectangle too, those being congruent, those being congruent. So it could be a rectangle or a square because we don't know the relationship. We don't know anything about these two sides, which would be those two sides and those two sides. So it's possible it could be a rectangle, a square, or an isosceles trapezoid. We just don't know enough information. Daily homework quiz number 1. Number 2, and last slide coming up here. No one's turning in the extra credit anymore. You guys are getting lazy.